year. Now we have the third of free meetings which started this autumn. And we will we'll invite you also for the spring season next term, next semester. But this is our last meeting this semester. So the floor is yours, Lena. Please tell us something about you, and yes, you can share the screen as we can see. Yeah. It's working.
Thank you, Marta, for the introduction. Yeah. So hi, I'm Lena. I'm a professor here at the Film University in Potsdam-Babelsberg. I'm part of the Creative Technologies group, and my professorship is visual media technologies or image-based media technologies. So it's pretty much media computer science, but of course in a very artistic, creative context such as the Film University. And yes, so sustainability or sustainable creative media production is one of my research areas. I've been working on it quite intensely for over a year now in different projects. And one of the areas is IT systems, or like clean IT, which of course is also VFX or post-production is part of that. And also I wanted to say apologies for not showing up last time for everybody who wanted to attend in December. I got quite sick and I was believing all morning I could make it, but then during lunch my fever was just spiking. So sorry for that short minute cancellation. Alrighty, so without any further ado, let me start my presentation. So in this talk, as I've already mentioned, Marta has already introduced, so the focus is on VFX and post-production, or as I already said, IT systems. It will be a very, I would say, also academic, but also hopefully intuitive presentation. So I'm spanning a whole spectrum of topics. Of course, always with the goal of a green future, and a green future, just as like a nice start, I asked an AI to visualize a green future or a green desirable future, and this is one of the versions how it could look like. And with that image, I have my mandatory mentioning of AI done, so we can move on to sustainability in VFX, or my presentation of today. So what I will cover is a clarification of terms such as green and clean and so on. This might be maybe a little bit redundant to you, but then again, I really like to start with these basics one more time so that everybody is really aware of what's going on and what we are talking about. And then I will go over to current numbers and activities in film production with one example of a VFX department. But then, based on that, what is currently going on, I will present to you maybe a little bit a harsh reality check with some actual computations that are needed. We will see what that means. Okay, so let's very briefly reconsider what is actually meant when we talk about green and clean and sustainable and these kind of things. You hear a lot like green production, green film production. So I think that's quite straightforward. So with green, we mean processes and products with a low environmental impact. So meaning with having as little impact onto our ecosystem as possible. And for example, if we talk about green production or greening a production, a definition is the basic principles behind greening a production include conserving fuel and energy and avoiding toxins and pollution, saving water, reducing plastic, and preventing landfill waste. So why I like to mention it here is really to show one more time there are so many dimensions to this problem. So of course, and I will come back to CO2 and I will explain to you why, but there are also, toxins, saving water, plastics, and all these things. And what you might have heard in terms of VFX and IT is also the terminology of calling something clean. So clean originally was used for sustainable energy sources, so energy coming from non-fossil renewable energy sources like wind or sun. So originally that's where that term comes from, but in the context of VFX and IT, so you often hear clean IT, it means that, or it's usually used as IT with low energy consumption. And here the idea is that we are going more and more into the development of technologies that are sustainable by design. So the idea here, for example, clean IT research is really targeting that the software already, like when we write the software, let's say 3D software for VFX or compositing software, that already by writing the software, the coding, we try to make the software as sustainable as possible. And the main factor here is still like the low energy consumption. Just to give you a brief intro into these different aspects and why the whole thing. And once again, this is no news, but I like to mention it over and over again. What is the problem? I said there are various problems, but the main problem as of now is the global warming of our atmosphere. So in this this warming of our atmosphere is based on our emission of greenhouse gases, coming, for example, from fuel and non-clean energy sources, but also from certain agricultural processes. So we have the problem that we emit a lot of carbon dioxide, CO2. There are other greenhouse gases, so that's why you have sometimes the E for equivalence behind that. And by doing so, we warm up our atmosphere. And so if we continue to live like we live now, like emitting the CO2 gases that we are emitting, so we are heading towards an increase of temperature between 4 and 5 degrees. If we are continuing like we are currently continuing, so no changes, we are heading towards 2 to 3 degrees. And if we are implementing, and we are almost already failing that, we are heading towards 2 degrees of temperature increase. And I like to give here the example that it is quite fitting, because last time I couldn't give the talk because I had a fever. Imagine how you as a human being feel like having a fever. So if you have a fever of, let's say, 38 degrees, that's of course not life-threatening, but already quite limiting. And by the way, so for example, in December, I had like 38.6, and I was like, no way I'm giving a talk, like I'm out of here. So, and we are heading towards a future where our Earth is operating in a way as if, and of course it's not the same, but as if we have to operate with 38 to 39 degrees of fever. So here we are really heading into a future which is not good. It is as if we are heading into a future where our planet has constantly between 38 and 39 degrees of fever. And I'm not saying we are having them constantly. It's just an analogy. And I like to paint the picture like this. Okay, so that's the problem, and that's beyond all the different aspects that I have mentioned. CO2 emission is still like a really dominant, or maybe even the dominant aspect here. And for that, for our CO2 emission, I also like to give you, or it makes it a little bit easier to also have this intuitive quantification, especially when we talk about how much does VFX, for example, need. So usually, or you probably already also know that we often talk as measurement as 1 ton of CO2. So what can we understand as 1 ton of CO2 intuitively? So this is a very much an average or like an oversimplification, but you probably know, or you might know, maybe not, then that's of course fine. One intercontinental flight between Paris and New York is 1 ton of CO2 emission. So you are causing 1 ton of CO2 emission. As comparison, the annual consumption of an average household is only 0.65 tons. So with flying across country, across continents, you are causing more than an average household of CO2 emission. Again, very oversimplifications. They're of course very different households. So I'm just giving you like a little bit of a feeling for where we are at. Similarly, a year of a gas car, so gasoline car, is 0.5 tons. Sorry, so 1 ton, so half a ton is so 0.5, 1 ton is half a year of gas and 1 year of electric car usage. Apologies, I was confusing myself there. Also, again, a very overgeneralization, but just to give you a couple of ideas. For example, there are also some studies or some numbers that say 1 ton of CO2 is roughly 140 meat dishes and 2,000 vegetarian dishes. Again, oversimplification. There can be a big schnitzel and there can be a small, and there can be like sustainable meat production and non-sustainable, but just these numbers, and they are all based on something, so I didn't make them up. And to be honest, which is also interesting, there are a lot of studies that compute or investigate the damages caused by CO2 emission, and so roughly speaking, that is a number from a German ministry saying, okay, the emission of 1 ton of CO2 amounts to damages approximately of 180 euros. By the way, there are also these calculations in terms of deaths, human deaths. I spare you those at this point. And also what I really like as a feeling or as a comparison, to absorb 1 ton of CO2. So if we emit 1 ton of CO2, let's say by flying from Berlin to New York, 50 trees must grow for 1 year to absorb that emission. So that's good news and bad news. We have the trees, they are doing the work for us, but for 1 ton, we need 50 trees to grow. So they also need to be in the process of growing. Just to give you, like when we talk about CO2 tons in the following, that you know a little bit where we are in terms of comparison damages and so on. And you of course know, or you have heard of the CO2 footprint. So this is a very valuable and meaningful measurement. So for example, you do something and then you compute the total amount of CO2 that is emitted by that action. And that is generally used as or understood as CO2 footprint. And it is a really also a valuable feature potentially in an economic context. So I personally believe and hope that we are heading towards a future where we don't only invoice the money. So currently, if we do something, you get an invoice, it tells you how much it costs in terms of money. I could imagine that we are heading towards a future where we have the cost of money and the cost of CO2. That would be nice in my opinion. But it's also very difficult because these computations are still so difficult. Yeah, so the correct determination here, and you will see in a second an example for that, is still very, very difficult. However, which is also maybe a fun fact or not so fun fact, and we see with that also the complexity of these approaches, actually the term CO2 footprint became popular through a 100 million marketing campaign by BP. So one of the oil and gas, one of the biggest oil and gas companies, so one of the dirtiest companies you can imagine. And they actually pushed advertisement companies beginning of the 2000s. So it was, sorry, let me check. It was 2004 to 2006, where they say, what on earth is the carbon footprint as one of the advertisements? And they say, reduce your carbon footprint. So the intention here was to deflect all the responsibilities into a personal space. So even though CO2, so I like to mention this, so I'm not saying, so CO2 footprint is still a good thing to calculate, but it is kind of interesting where it's coming from. Let's say it like this. In general, I also want to introduce want to mention in the beginning, of course, the topic of greenwashing. There are very fine lines. We will see that with the current computations of CO2. The overall idea, of course, you can also say talk clean, act dirty. And this is a big problem in our times currently still, like these marketings and like a selling and so on. And the problem is here that there are really few standards and there's almost nothing legally binding in terms of measurements or values. And we have a problem with images and symbols. Coming back to our non-so friends at BP, look at their logo. I mean, they are trying to brainwash us here thinking that BP is really, really green. Or you see a lot that, for example, in advertisement, that they try to offer us something at a solution which is just not relevant. So, for example, Exxon, another oil and gas company with coal and so on, they had an advertisement campaign that said, let's use algae. Do I say that correctly? Like the tiny green things in the ocean, like the algae. Is that how you pronounce it? Okay, Marta's nicking, so that's good. So they said, hey, let's look, it's tiny, it's green, and could be the future of biofuels. And there was no real scientific evidence or significance that this would be a relevant thing for us. But they made a big advertisement out of it. Yeah, so, and another thing you might have heard, which I don't want to like criticize in general, but it is a little bit also maybe ironic, is the CO2 compensation, where, for example, I like this image. Imagine CO2 compensation is as if you're killing a panda bear and then you are giving money to WWF, like the organization which is for wildlife preservation. So, of course, CO2 compensation is better than nothing, but yeah, it's maybe not the only solution out there. Let's say it like this. Okay, so yeah, so greenwashing is a problem, and the lines are fine. Like, where are we? Because the actual values are really hard to find and control. And what I guess my message here really is for now is be careful, be attentive, look out for like a little bit like these brainwashing things also on products. And we as content creators or even maybe companies or startups, we really just have to be truthfully sustainable in what we do. So we need here transparency and accountability. We need different kinds of approaches. And of course, we still need to stay close to reality. And these are obviously very difficult questions. Okay, and with that, so now we know we are at what problems are and so on. Let's move into looking at current numbers and activities where we at with film production. Let's start with that. You probably, I could imagine, have already some heard about this. So what I can really recommend is a nice report from the Sustainable Production Alliance in North America, the US, where many big players like Disney, Fox, NBC, Netflix, Amazon, they all participate in this alliance, and they have a lot of numbers and studies. And for example, this report shows some numbers for the average CO2 emission of films, and they differentiate here between like the blockbuster called the tentpole on the left side, moving to large, medium, and small productions. So in Europe, we are probably in the area of the small production, maybe with a couple of medium, I don't know. But so of course the blockbusters is something a little bit less frequent for us. And so what they say or what they show is that film productions range from 3,000 tons for the blockbusters to around 400 tons for the small production. So 3,000 tons. So now you can think, okay, it's approximately like 3,000 flights from Berlin to New York. It's 1,500 cars so per year. So I'm not saying which is better or worse, but there you have a little bit of a comparison. And to go maybe even smaller, so let's have a look. So at our school, Film University in Potsdam, Germany, we actually are very active with production. So we have up to 100 productions per year. I would call them mini productions. So I don't know. I don't have any actual measurements as of now. We are working on that. But so I said these productions have probably between 5 to 10 tons, or maybe even just 1 to 10 tons, depending on if there's traveling or so. But this means that even we, as just a film school, have approximately up to 1,000 tons CO2 emission per year just by our production. And that means painting the picture even a little bit more intuitive or dramatic. Film University needs between 25,000 and 50,000 growing trees for an absorption of our CO2 production. These numbers are a little bit fishy, so don't quote me on that, but just an overall, let it be 10,000 trees per year. It's still a lot. Yes, and so that's where we are in film production. There are thankfully a lot of activities for sustainability. So similarly, starting in North America, we have the Green Production Guide, where they give you a lot of insights. So for example, saying, so it's by film industry leaders, and they offer tools, resources, and vendors for reducing your environmental impact. So it's really good, but it comes with a lot of also limits. Similarly, we have, for example, in Italy, Green Film, Film Group. They also published guidelines. In Germany, we have Green Shooting guidelines. So there's a lot of happening. But I would argue there is still so much work left to do. Showing you one example from Germany to start. So they have a project called 100 Green Productions, where they tried to reduce the CO2 footprint of 100 productions, and they actually succeeded. So for example, all the Germans know what a Tatort is. So every Sunday evening in Germany, there's like one format which is called Tatort. It's a crime movie. So, and this is like a very constant in the German media production. So this is always a good example. And they showed that for one of these productions, because there's so many of them, they could easily compare it. They showed for following the guidelines, they could reduce the CO2 emission by 42%. And they also split it. So on the left side, you have the traditional production capabilities, and apologies that there's still some German left over, but so it's offices, airplanes, trains, taxi, transport, energy, waste, catering, and hotels. And on the right side, on the left side, you have the reduced, so the improved, the following the guidelines. On the right side, you have the non-optimized, and you see also here flying and hotels are quite dominant. However, bad news, so we know stuff. So we have knowledge on how to really reduce the CO2 footprint. However, in the Sustainable Production Alliance report from 2022, they also show, or they ask in production environments about the degree or the percentage that they actually execute the guidelines for green productions. And what they show is so that only 8% of the people or of the environments they ask implemented more than 80% of the guidelines. So what I say is like only 8% say they are implementing most of the guidelines. That is like this expected value in the top. And 44% of the people or the companies they ask said they implement less than 40% of the guideline, like less of half of the guidelines. So there's really still a lot of work to do with like actually implementing the guidelines that we have. I showed you there are so many of them, but currently we really have to work on making them, bringing them into reality. Okay, and moving now slowly towards our topic of post-production. So apologies again for the German. So what you see here is sector shares from film production. So on top we have transportation, and then and the percentage of CO2 emission. And so we have materials, catering, offices, post-production, and production environment, the studio. And you see an average only 2% makes up for VFX and post-production, what we are talking about. However, there's a huge range. So it goes from 2% to 26% of the CO2 emission. Also shown here with like these are the 100 greened production in Germany once again, and the yellow, so it's what you see is the total emission of CO2 and the different sector shares, and the orange is the VFX. And you see there's like on the left side there's quite an influential VFX, and then there are a couple of productions where you can't even see it. So it varies a lot. However, why these numbers are not so trustworthy is another thing I will explain to you during the course of this presentation. So let's have a closer look at visual effects. And actually what I wanted, or I'm already telling you, you should, as of now, with the given guidelines that we have, you need to consider this as post-production. Because, for example, there are a bunch of calculation tools and mechanisms, and they only consider the creation of visual effects in the post-production workflow or as post-production. However, modern VFX technologies or developments actually break that, and we go from post-production, for example, with real-time engine or LED walls to create these visual effects. They are moving into actually early in the production. So this is already a problem that in almost all standards that I know of, they have a very rigid definition of what VFX is and where it is. And they really put it like as it is traditionally into the end of the production as post-production. And also, once again, what I mentioned here, we really mean anything from like creating like these virtual worlds, like here from the movie 2012, where like it's VFX all over. But you also have to add up the small productions, because in the end, almost all productions have some form of CGI, so computer-generated images. So for example, this looks like a real image, but the birds were added. So not like VFX or visual effects are not always visible. So what are the components or the relevant aspects or parameters to think about CO2 for visual effects or post-production, as we have to say? So of course you have hardware. So you have computers, you have displays, you have servers, you have LED walls, that are kind of like the main components. Cloud computing might come also in and so on. And for this hardware, you have to consider the usage hours. How many hours? You have to consider what type of energy. Is it energy coming from renewable sources? Is this fossil energy and so on? And then you have to consider the external services. So in current VFX production, cloud storage and cloud computing, for example, for rendering, sending the computation of the final image is so complex that these days you often send it to what is called a render farm. So a render farm is, you can imagine it like this cloud service, which is somewhere virtual, and you send your rendering job there and they compute it for you. So hardware usage, type of energy used in external services is what is currently mainly represented. And the question is here how to measure. And one example or one current approach of doing so are the CO2 calculators, which all the different initiatives have. This is the German one, the CO2 calculator. And the idea is, and it's actually quite relevant in Germany, but also in other countries, because thankfully, I mean, that's a good thing. But for certain funding, and in Germany, film production is heavily funded or is heavily based on funding, getting public funding, you have to give them a CO2 budget of a production. And you can use these calculators to do these budget calculations. So, oops, apology, wrong direction. So you would calculate the CO2 emission in kilogram. And then if you show that if you are below certain numbers, you get the funding. And I mean, it's a good idea, but as of now, all the calculators I know are very limited, and I will show you why. So for example, the German calculator has as categories energy, travel, transportation, catering, and materials. It looks like this. You can select a category and then you put in certain values. And here you have the value that you can give the source of the hardware source. So let's say CPU computer, a GPU computer, so with graphics processing. You say how many of these computers or nodes. You say whether you have a smart use of the emitted heat. So heat waste usage is also a thing here, and you can give it the usage hour. So this is really an example of this tool, which is very comparable to all the other tools. So you would, for example, go in and say, hey, I have a CPU rendering, or I have a GPU rendering, so rendering on the graphics card. And then you can say something like, okay, I'm having a grading place. So it's not giving you the hardware, it's just saying what you're doing with that, a grading place, or you have an editing desktop, or you have a motion design desktop or computer seat. So it's very weirdly generalized and not very precise. But okay, let's say we are using that, and let's say, okay, we are VFX department, and we have workstations that work 8 hours a day, and we're using a server farm for rendering that is 20 hours a day. So now we have to count what do we have. So let's say we have 5 budget computers, that each budget computer has a monitor or display. We have 10 mid-range computers with 2 monitors or displays, sorry. And you have 10 high-end computers, let's say like gaming computers, also with 2 displays, and you're using a server, a render farm, a server farm. So now that would be your start, which you need to analyze and which you could put in the tool I just showed. And then the tool would give you the numbers for that setup. So like I said, we have a budget computer. So one budget computer emits 0.5 kilogram if you use normal energy or non-green, and with green it's a fraction of that. So the usage of green energies does a lot. For the mid-range computers with 2 displays, you are a little bit higher, so 0.7 kilograms. Once again, dramatically reduced by the usage of green electricity, which you can put into the calculator. High-end computers are between 0.8 and 0.1 kilogram. We are in kilogram now, not tons. We will move it into the tons at the end. And let's say we have a server farm, so meaning a lot of nodes that do the computation for us. So let's say we have a CPU render farm with 100 nodes, air conditioned. It's between 300 kilograms and 20 kilograms with green energy. Or when we use the emitted heat to create energy again. So we are between 230 and 16. And then with the GPU, so with the different hardware, we are already dramatically higher. So we are between 900 kilograms and 60 kilograms and 700 kilograms and 50. However, or let's say, so in total, coming back to tons, so in our best case scenario for our VFX department, so if we use green electricity, we make smart use of the heat base, we use the CPU farm, we are at 21 kilogram a day, so we would have 1 ton in 50 days, which is quite a long time. If we use GPU, so different hardware, we are at 50 kilograms, 1 ton in 18 days. So give me a moment. This is very dry, I know, but we are moving on in a second. So in the worst case scenario, we are at 300 kilogram, so if we use air condition and the CPU farm non-green energy, we are already at 1 ton in 3 days. So now we are dramatically like being worse. And if we use a GPU farm, so we are at 1 ton with this render farm in 1 day. So intuitively, you might say with this calculator, hey, let's not do GPU rendering. Because that's so much worse. What's not considered here, and this is of course very complex, GPU rendering is much faster than CPU rendering. So an image that I compute with the CPU renderer might take, let's say, 3 days. These are fantasy numbers. But if I do the same render job with the GPU, this might just be 1 day. So you see how complex this is and how limited this is. And also what I want to mention here, so you have seen really like these big changes between using green electricity and non-green. So like using renewable energy sources versus fossil energy sources. So what I hear a lot when I ask in the industry, it's like we are using green energy, so all is good. And they are actually supported by these calculators to think so, because they are just referring to the usage of the hardware. But you might think already a second, what do we need beyond the usage of the hardware? Well, the emission of the manufacturing and disposal processes. And so there's very reliable data from a colleague of mine who does research exactly like this. So for big data center, it's true, 80% of the CO2 emission is in the use phase. However, for like end consumer products like a computer, a notebook, a smartphone, a display, actually 75 to up almost 100% of the CO2 emission when we look at the whole life cycle of these products come from the manufacturing process. So anytime, so buying a new computer has, for like a production, for example, for a VFX production, is much more influential or significant for the CO2 emission than the usage of the computer over like 100 days or so. Or, I mean, these are, of course, also, I don't have like a good comparison of these like VFX department numbers. I'm just telling you here what here really the take-home message is. You always have to consider the manufacturing and disposal processes of the hardware you are using. So if you're VFX, and the calculators, by the way, they are just looking at usage. So if a production buys 100 new computers for their production, this is like so much worse than a company that just uses their hardware. And of course, that's also reasonable to do so because you save money with not buying new hardware. But it's relevant, and it would be nice if these calculators or standards would be a little bit more, would be a little bit better in enforcing also these aspects, like the reusage of hardware. And of course, with hardware, it's not that just the CO2, like for computers, a lot of like sources, so from the earth, I'm missing the English here, like production sources like sand or minerals or whatever there's needed, that's all in there too. So, and to know a little bit more, so life cycle assessment is really relevant for like these consumer products or for these products we are using in VFX on post-production. Actually, and how do you know these? How do you know what is the cost of the manufacturing? Well, so it's a manual, very tedious process to find this out, to figure this out. Some production, some hardware companies actually offer it to you, and I'm by no way like want to advertise Dell products, but they do stand out a little bit because on their website, so I'm just giving you a screenshot of the Dell website, for every single of their products, they give you a life cycle assessment. So for example, let me show it to you real quick. Give me 1 second. So here, for example, you have the 27-inch monitor, and they give you for the whole life cycle the CO2. So if I go here, they give you a sheet like this, and they really consider like all the steps of, they even go towards packaging and so on. So they give you really nice information about a truthful assessment from start to finish of their products. And this is really useful, but of course it's very like spread the information. You as a user or you as a company have to collect this data and find it. But also, it's still, even if you have that data, it's very difficult because, for example, if you look at the storage system of Dell, they actually tell you, well, the CO2 footprint really on the life cycle assessment really depends on the configuration. And what they give you in their sheet that I just showed you, they say, well, the storage system can be between 4,000, so 4 tons CO2, up until 226. So there is a huge range between how you use the hardware. So you see, it's really, really difficult. But I really would like to encourage you, if you are in the business of computing a sustainability value for production or CO2 footprint, this is relevant. So really also consider the manufacturing processes of the hardware we are using. And now I want to give you an even more depressing, no, not depressing, but also tedious reality check of what we actually have to calculate if we really want to have a true CO2 footprint in reality, if we want to have true values. So and let's say from a VFX department, but this is actually applicable to any kind of IT. So let's say, okay, we have a couple of devices. We have computers, we have displays, we have smartphones, we have a router, and so on. So we have the devices. Then we have to consider the CO2 footprint of the communication networks we are using. So how are we sending data, for example, to our backup storage, as well as through the internet? So we have these telecommunication networks. And then we have a data center. So like I said, this is representing, for example, rendering, using a render farm for VFX. And now what you need to compute, and I'm going over it a little bit superficial, but so all the values you would need is the annual CO2 cost of the manufacturing of your device. So CO2 for the device manufacturing, and you would need the energy used bis usage, so when you use the actual device, and you need to know the CO2 of the standby. So a lot of companies use standby, they don't turn off their devices. So we are now aiming towards, let's say, an annual emission value. So we need the manufacturing, we need the usage, and we need the standby. Also, by the way, also green energy. I was in a 1 hour talk that just was about the CO2 emission from the energy used, and that green energy is not equal green energy. So even if you say you have green energy, there's still, of course, CO2 emission from it. So, and there are very complicated mixes. So you would also need to know to really identify, okay, what is the CO2 emission from my electricity used? Then you have the telecommunication networks, let's say sending data through the internet to your data center. Here again, very complex problem, because you're not the only one. So I'm just showing you, you don't have to understand this diagram. Apologies if it looks scary, but it's like a communication network has so many different components. And for example, it's used by various companies at the same time. So how do you know what your data sending is using? So this in itself is like a really complex problem to compute the CO2 emission from your network usage. But here, so you would in theory need the CO2 emission from your data transfer, and then coming to the data center, to the render farm. And the render farms, so these data centers actually, thankfully, are very well researched by now. So we have a lot of information about these data or render farms in regard to their server, storage, networking, cooling systems, energy consumption, and actually, which is a good thing, they're using this also as marketing. But here still there are open questions. So for example, we have no standards whether we define them by cost per service or, for example, cost per data amount. So are we charging or are we computing CO2 by the hour, or are we computing CO2 by the terabyte? And they all do it differently. So almost no comparison possible there. But so let's say we are VFX department or company, we want to know our CO2 footprint. So what in reality, if you really want to have a precise number, so in summary, what we need to do is so CO2 for the, so this is just a summary of what I just showed you. So CO2 for the device manufacturing. So this means the annual use in hours, the use in hours, the standby in hours, multiplied by the emission from the energy used. Similar, we need the emissions from the data transfer multiplied by the emission used, the emission from the energy used, and we need to have these values from our data centers or render farms used. And I know maybe this was really hard to follow because I have all these. It's a little bit more precise, so I simplified it a little bit. So you also have all these watt and these the units here. But so if you would compute this you would have a fairly accurate billing or costs, CO2 costs per year. But as I've seen, so for example, with the networks, it's almost impossible. You would also once again go to averages, and we don't even have good averages here. Yeah. So what can you do as a VFX department? How can you measure your sustainability? So I showed you the CO2 calculators briefly. Once again, they are almost all, or they are, to my knowledge, they are all based on just the usage. They are not investigating life cycle. You can rely on information from manufacturers. I showed you the example of Dell. They are doing quite a good job there. Or you can measure and calculate your data yourself. I gave you the formula for that. Good luck. No, but yeah, so it's all very laborious and difficult at the moment, and it's really like we are at the beginning of getting this right. That's what I also really want to say here. So hopefully by throwing a little bit of complexity to you here is that you really understand where we are at. And yeah, so maybe breaking it down a little bit more practical, what you can look out for is, yeah, like I said, hardware specifications, having maybe in your company or in your team rules for acquisition, updating and disposal, define maybe rules for your company. When is it okay to buy something new and when not, and where does your stuff go? Make sure that you compute both usage hours and standby hours, but ideally maybe, oops, apologies, wrong direction. Ideally also think about resource sharing, try to avoid idle times, and with that buying more hardware, but maybe using the hardware you have more smartly. A way to go, this is for small companies not so achievable yet, but so for bigger companies with big vendor farms, think about using the wasted heat. So you can use the heat that is emitted from your hardware to use as energy again, and big data centers are doing that. Look, of course, at the energy used, of course. So I'm not saying that this is not relevant, but it's not enough. And like I said, I hear this all the time, that companies tell me it's fine, we're using green energy. Using green energy is of course really good, but it's not the end of the solution, or it's not just the solution. And if you use services, you as a consumer can of course put pressure on really asking for CO2 numbers and footprints from the services you're using. Yeah, and with that, I'm coming to an end. And yeah, let's maybe try to get here. I mean, this is of course purely fictional and generated from an AI, but yeah, let's keep our planet green and let's not kill all the living things here. And yeah, so these are my contact details. Yeah, and I hope you took something from my talk. Thank you.
Yes, it was really interesting. And what is your motivation? Because it's mainly IT based, yes, and counting energy used by the computers and engines like GPU, CPU. What was your main interest and how you was leaded into such topic, Lena?
Okay, so first of all, this is not only my focus in my normal life. So I was recruited by Sophie and Björn for this topic. So I'm a computer science by training. So of course, that's where my interest lies. But for example, I personally, and that's how I got there, because I'm doing a lot of computer science. I'm doing a lot of VFX. I used to be a VFX artist myself. So that's where that interest naturally came from. But to be honest, let me say that as of now, I think we need to focus a lot also on the contexts. Like I said, we have so many standards. What do we need beyond these calculations? What do we need beyond the knowledge? how can we really influence people to change and to adapt and to use these standards that we have, or to do this calculation. And this is also something I'm investigating, but of course also I'm not that qualified with coming from computer science. I don't know that much about how to influence people or society, but that's to me equally of equal interest. Yeah. Any other questions or thoughts or comments? I'm always curious also to hear what other people's thoughts are. If you have some comment, that's also fine. If someone wants to say something.
Yes, you can ask freely or just, oh yes, Vivian, please go.
Yes, hi. I wanted to ask if you maybe have like a recommendation for these render farms. Is there anything here in Germany that would be really recommendable to use, or how do you find out?
That's a very good question. So lately I haven't checked. So the last time I checked this was for another talk I did, which was in September 23. And I have to say, I was really underwhelmed by the information I could find. So basically, there was almost none of this for the render farms. But I'm also equally interested in this topic, so feel free to drop me an email and we can together find some information on this. But last time I checked for specifically the render farms, so VFX render farms, I couldn't find any information on that.
Okay.
But this is something we should all ask these providers, because we as consumers here should push them on giving that, and at least using green energy, at least using the heat waste and so on. Very important and good question. Unfortunately, I cannot answer.
No problem. Okay. And one more. At the beginning, you said like it already starts with the 3D software with the coding. If I'm, for example, like a green consultant in a little production firm, what do I like recommend someone who is like doing the VFX thing in general? As I'm not totally into the VFX stuff, but in the production stuff, how can I like recommend something that they can use for themselves, even though I don't know something about programming or coding?
Yeah. So again, unfortunately, I have to disappoint you here with a non-specific answer. This idea, sustainability by design within IT, is currently starting in academia. So they're actually in Germany, they started just last year a big research project where they investigate how you can reduce energy consumption by the code itself. It's not yet reached in the industry. So there are some examples outside of film production or creative media or audiovisual media production. But to my knowledge, as of now, in our industry, it's not part of the software yet. Let me think. No. So this is really more like a research topic, but a really nice or really relevant. And this is, for example, what is called clean IT. So that's like how I introduced it. And for example, our colleagues at Hasso-Plattner Institute in Potsdam-Babelsberg, they have a research institute where they try to get further with that. But as of now, it's not reaching the industry yet. But it's a really relevant problem also with machine learning, if I might add. So it's really fun, not funny, but so for these machine learning algorithms that are based on machine learning. So for example, the training of a machine learning algorithm is hugely have a huge impact, So one can argue, okay, the learning, so the training of these algorithms is not done every time I use the software, not at all, but it is done to get these AI-based software. So whenever I train a machine learning algorithm, it needs so much energy and so much, with that, it produces a lot of CO2. I forgot some concrete numbers, but it's really also an issue. So it's really good that we are starting to consider these things. As of now in machine learning, we are more concerned with accuracy, so that we have good results, not yet so much that it's an efficient result, but it's starting to get there. But I always am sorry, I go far beyond what you asked, but just finishing that thought, I always so I had a friend who is a computer science PhD student, and he's very ecologically aware, and he has no car and he didn't fly, but his research topic was AI. So he did a lot of algorithm training during the day, which was when he was aware, but so it almost produced as if he would drive a car and fly and all the time. So this is really relevant these days for the development of new software. But yeah, once again, unfortunately, I have to disappoint with, I cannot give a concrete answer.
Okay, thank you nevertheless.
Okay, anything else? If not, I mean, feel free to reach out. I will definitely investigate render farms myself. It's good that you reminded me, because I haven't done in a couple of months. Yeah, feel free to reach out if you want to know more, want to work together, or have ideas. And then, Marta, I don't know, with that, should we close or?
Yes, we can thank you to be our guest. We are sorry that you had such bad fever, last time, but it was good example and we will remember it.
Yeah, I just realized when talking about it.
Yes, so thank you, Lina. It was pleasure to host you during our meeting, and we have your email, so we will be in touch.
Thank you. Bye.
Thank you. Have a nice afternoon.
Thank you.
Or evening.
Bye-bye.
Yeah, bye-bye.